Assalamualaikum. Hi everyone, I'm Cikgu Niswan. Okay students, these are learning outcomes you should understand at the end of this video. This is a type of equipment to perform titration. The titrant is the solution being slowly added from burette to a solution in the receiving flask. The pH of the solution being titrated changes with the addition of titrant. When the pH of solution at different stages of a titration is plotted against the volume of titrant added, we obtain a titration curve. The titration curve plots can be experimentally measured using pH meter or can be calculated by the procedures we will discuss after this. You must have an idea. The titration curve is sigmoidal in shape, that is curved in two directions, like the letter S. The equivalence point lies at the midpoint of the extrapolated vertical portion of the curve. Students, you should know that there are two types of buffer solutions. The first one, acidic buffer solution. Acidic buffer can be prepared by mixing a weak acid and salt of weak acid. Example, aqueous mixture of ethanoic acid and sodium ethanoate. We know that ethanoic acid, a weak acid, which will dissociate partially in water. On the other hand, sodium ethanoate dissociates completely in water. Thus, the mixture of the two solutions contain a large concentration of undissociated ethanoic acid and ethanoate ion. You can see that solutions that contain weak acid and its conjugate base also is called buffer. Second type is alkaline buffer solution. Example, aqueous mixture of ammonia and ammonium chloride. Ammonia is only partially dissociated and ammonium chloride is fully dissociated. A mixture of the two in aqueous solution contains a high concentration of ammonia molecules and ammonium ions. Buffer solution also can be prepared by titrating a weak acid to a strong base, a weak base to a strong acid. Let us discuss when 25 cubic centimeters of 0.1 molar ethanoic acid was titrated with 0.1 molar sodium hydroxide solution. Basically, this is weak acid strong base titration. Bear in mind that ethanoic acid is weak acid and partially dissociated in water. To determine the concentration of hydrogen ion and pH for a weak acid, we must determine the initial and equilibrium concentrations of the species present. It is very convenient to use this kind of table. Take the given concentration 0.1 molar to be the initial concentration of ethanoic acid before any dissociation has occurred. Let X be a very small amount of molecule ethanoic acid that ionize per liter. We make approximation, X will be very small compared to 0.1 molar. So, at equilibrium, the concentration of ethanoic acid equivalents to 0.1 molar. Substituting the equilibrium concentration values for each species in the last row into the Ka expression will give us the value of X, that is concentration of hydrogen ion. If you still remember from Oswald dilution law, we can also use this formula to get the same value of concentration of hydrogen ion. pH of given weak ethanoic acid before any sodium hydroxide is added is 2.87. Now, let's see when we add 10 cubic centimeter of sodium hydroxide into the 25 cubic centimeter ethanoic acid. As we add sodium hydroxide, the reaction will produce sodium ethanoate salt, meaning that the solution contains both ethanoic acid and ethanoate ion. So it is a buffer solution. From stoichiometry of the reaction, we can see that ethanoic acid is the excess reactant since sodium hydroxide is completely consumed in the reaction. Thus, the concentration of ethanoic acid is 4.29 times 10 to the negative 2 molar, and concentration of sodium ethanoate salt is 2.86 times 10 to the negative 2 molar. Since this mixture solution is acidic buffer, we can use this equation to calculate the pH. So, the pH is 4.56. Now you can see that the pH of solution being titrated changes with the addition of titrant. Okay students, please recall that water is a very weak electrolyte, undergoes self-dissociation, also referred to as self-ionization or auto-dissociation. Please take note, here we have made a critical and correct assumption. We will assume that all the hydrogen ion in the solution of acid comes from the solute, and in a solution of base, all the hydroxide ions comes from the dissociation of the solute. Anyway, the auto-ionization of water cannot be ignored when working with very dilute solutions of acids and base. Now, we add 12.5 cubic centimeters of sodium hydroxide. Again, sodium hydroxide will completely use up, and ethanoic acid is in excess, producing sodium ethanoate salt. It's still buffer solution. From excess mole of ethanoic acid, its concentration is 3.33 times 10 to the negative 2 molar, which is equal to the concentration of the sodium ethanoate salt. Okay guys, please take note that here, when mole of acid equal to the mole of salt, definitely concentration of acid will equal to the concentration of the salt. Using the formula, pH of the solution is 4.74, which is equal to the value of pKa. Now, we will see when we add 25 cubic centimeters of sodium hydroxide into the ethanoic acid. At this point, we have exactly neutralized all of the acid with the base, and neither ethanoic acid nor sodium hydroxide are in excess. All ethanoic acid and sodium hydroxide has completely reacted, and solution contains sodium ethanoate salt. The anion CH3COO negative will undergo hydrolysis. Since ethanoate ion is a base, we have to use the Kb expression. We start with writing a chemical equation for hydrolysis of ethanoate ion. Finally, calculated pH of the solution is 8.7. This shows that the pH at equivalent point is basic. Proven that in the titration of any weak acid and strong base, the pH of equivalent point will be greater than 7. Okay guys, one of the character of buffer solution is its buffer capacity. Buffer capacity of buffer solution is the amount of acid or base that the buffer solution can absorb without a significant change in the pH of the solution. And the solution has maximum buffering capacity, and this happens at the halfway stage of the titration. For the buffer action to be effective, the ratio concentration of salt to the concentration of acid can only be varied within the limits of about 10/1 to 1/10, that is, pH equal to pKa plus minus 1. Now students, try to answer these two related questions. That's all for today students. See you in the next section. Bye!